Hey, this is Warren Redlick. Update on the Boring Company.
I mean, would it be incredible if you could travel around LA, New York, DC, Chicago, Paris, London, anywhere at 150 miles an hour? That'd be phenomenal.
I had an interview recently with Will from Boring Revolution, a great channel on YouTube. During that interview, we talked about an update to the Boring Company FAQ. This happened somewhere between July 15th and July 19th. That the Boring Company FAQ page when it had a radical update. There's a ton more information there. We're going to go through it. Are you ready? Let's go. There's now 5 parts to the Boring Company FAQ. There used to be just a simple FAQ. There's now tunnels, TBM, loop, safety, and construction. We're going to go through each one of those. Some key details are the most exciting detail to me is about Prufrock. Prufrock is the future tunnel boring machine that Boring Company is working on that will be much faster and much more efficient and enable building a much larger tunnel network, making all of our lives better. So let's get going. First, on the tunneling section, I don't think a lot of this is new information, but they detail advantages of tunneling at some length. Unlimited capacity, you can build as many tunnels as you want. Minimal land use, the tunnels themselves go under land, so they don't really take up land. There's some land use for stations, but there's not a whole lot of land use. Benefits of tunneling include unlimited capacity. No practical limit to how many layers of tunnels can be built, so any current or future capacity outcome can be achieved. This flexibility contrasts with a surface system where adding a lane to the road is often difficult. This is a really big deal and one of the really big advantages of the Boring Company. It's very hard to build more roads on the surface because you're operating on a 2-dimensional surface. Tunnels operate in 3D, you can go deeper. And also, there's no buildings underground, so there's a lot more room even on one level. So, huge advantage for the Boring Company here. Another thing they mentioned, minimal land use. The tunnels don't use a lot of land on the surface. Same basic point. Yes, there would be some stations, there would be some spots where vehicles would come up and down from below, or people would come up and down from below, but most of the operations of the tunnel are underground, so they don't use surface land, which is valuable. And there's minimal surface impact, because the way tunneling works and the way tunnels operate, because it's deep enough, more than 30 feet underground, the impact of the tunneling and of the operation is not felt at ground level. If you've ever been in New York City and you've been above a subway, sometimes you feel it. The way the Boring Company plans on doing the tunnels, you shouldn't notice it from the surface, from up on top of the ground. Weatherproof operation, that's an obvious benefit of tunnels. They're not affected by weather. Flexible architecture, you can do different kinds of transportation with tunnels. There's a lot you can do. Future expansion, there's more, it's easy to expand a tunnel-based system, as opposed to how much more difficult it is to expand a road-based system or a rail-based system. It talks about why this hasn't been done before. It used to be that tunneling was very, very expensive. One of the key things that the Boring Company is trying to do is reduce the cost per mile of tunneling. What might have been common in the past and might still be common now, for it to cost $100 million or $1 billion a mile to do tunneling, the Boring Company is already under $10 million a mile. And based on my conversation with Will, we think they very well may get down to $5 million a mile or less. This is a fun part. This is Prufrock. Prufrock is the long-term goal. For those who haven't followed the Boring Company before, the first boring machine that did the tunnel in Hawthorne, California at SpaceX headquarters, that's called Godot. There was supposed to be an intermediate boring machine, tunnel boring machine called Linestorm. And as best I can tell from my conversation with Will, the machine that was used for the Las Vegas project was a mix of Godot and Linestorm, and it was achieving somewhat higher speeds, and it did get its cost down to maybe $7.7 million a mile instead of the $10 million a mile they've been talking about. The goal that they've talked about is Prufrock, which is a next generation machine that might be 10 times faster than Godot and start approaching the speed of a snail, which is still not very fast. Or one of the things they're going to talk about in a minute is getting up to 1/10 the speed or 1/7 the speed of a human walking, which could make a really big difference. So this picture that they have here is of Prufrock, and it's important to note the way they have it pictured. It's on a cradle, and this, we're going to explain this cradle in a minute, but notice that cradle. This is going to play into what's coming. As explained here, the boring company has iterated through 3 generations of tunnel boring machines. Godot was an off-the-shelf tunnel boring machine. Godot Plus was 50% faster. I guess they've left out Linestorm, so I guess the machine that they used in Las Vegas was Godot Plus, and they skipped over doing Linestorm. It used to be there was this idea they were going to have an intermediate machine called Linestorm, and it looks like they've given that up, and they're going straight to Prufrock. Each tunnel boring machine was developed to further increase tunneling speed and reduce tunneling cost. And Prufrock has been designed to launch directly from the surface and will achieve speeds of more than 10 times faster than Godot. We're going to come up to this again, but that's what that cradle is for, launching directly into the ground. The old style will explain this. The previous method that the boring company was using was you dig a big hole, you lower the tunnel boring machine into the hole, and then it bores from there. The model that they're using now, which has been done elsewhere, is you tilt it at the ground and let it bore straight into the ground, making a ramp down to whatever level it's going to, and that's more efficient. Old style tunnel boring machines typically dig a mile in 8 to 12 weeks, which is about 14 times slower than a garden snail, depending on which snail. Prufrock has been designed to tunnel greater than 1 mile per week with a long-term goal of tunneling at 1/10 of human walking speed, which is 7 miles a day. I believe they're saying human walking speed is 7 miles a day, so they would achieve 0.7 miles a day. That's actually a little bit unclear in the FAQ. How are they increasing tunneling speed? This is where we get to the surface launch, that cradle we saw in that photo. Launching the tunnel boring machine directly from the surface eliminates the need to excavate a launch pit, which is very expensive and slow. Instead, they arrive on a truck, tilt down, and is mining within 48 hours. Porpoising, diving down and diving back up, allows it to emerge at grade without necessitating the excavation of an expensive TBM retrieval pit. In other words, they would have to excavate a pit on both ends. And because of the way they're doing it, they don't have to do that. And at the same time, this creates a ramp down to the tunnel and a ramp out of the tunnel, which is also more efficient. Another thing to increase speed that they've talked about before is continuous mining. A lot of times with tunneling, they tunnel a certain distance and then they have to stop because they have to put things on the walls of the tunnel to keep the tunnel from collapsing. So they use precast concrete segments. The goal is to make it so that the concrete segments are put up as the machine keeps going and the machine doesn't need to stop while that is done. Maybe the machine is able to do it itself, or maybe they will have some sort of system behind the machine to install the segments as it moves. You want to triple the power. This is an important detail. If you have more power, you can grind away faster. Eliminating rail. This is another thing that I think this is very new on the FAQ page. This is something we haven't seen before from the boring company. I don't think it's that surprising, but in the past they have put rail-based locomotives to move things in and out of the tunnel. As they bore the tunnel, they lay rail behind it, and laying the rail takes time. And the boring company has adopted an approach where they use rubber-wheeled segment trucks that are carrying the concrete segments they're going to be putting up behind the boring machine. And doing that makes everything faster. And it prevents problems like if the locomotive falls off the rail. Another important thing is reducing the cost of tunneling. Their goal is to get below $10 million a mile through a variety of improvements. Vertical integration. They're producing the tunnel boring machines, electric construction vehicles, and the tunnel's precast concrete lining in-house. Instead of having outside vendors come in and do these things, the boring company is doing it for itself. This is how Tesla has managed to get their costs down. This is an important thing with SpaceX. It's a very common thing with Elon Musk companies is vertical integration.
So in the beginning, the top suppliers would not work with us, or we would get like their D team. They got all the customers, like they got the big car companies, they got like Toyota or Audi, BMW, Ford as customers, and a startup. Who now you're in the supplier's position. Which team are you going to assign to the startup that everyone says is going bankrupt? You're going to assign the interns and rejects. No, it's vertically integrate or die. There's a massive amount of work going from prototype to production, and so you need a fast feedback loop with engineering. And if that feedback loop is all the way out in Thailand, it's just no way.
They've reduced and standardized the tunnel diameter. Here they say reducing the tunnel diameter to 12 feet, a 30 to 60% reduction relative to standard transportation tunnel diameters. My recollection was that the original tunnel diameter they were shooting for was 14 feet. So this is an additional reduction. And they say maintain the same tunnel diameter for all projects in order to avoid reinventing the wheel each time the boring company designs a project and construction process. So number one, they want to standardize tunnel diameter because that allows them to mass produce the tunnel boring machines, which is the eventual goal. Again, Will and I talked about that in our interview. Check out that interview. Great interview, one of my best interviews so far. By going from what used to be maybe 28 feet tunnels down to 12 feet tunnels, it means number one, you have to excavate less dirt. So you're doing less work in terms of digging where you're digging, where the boring machine is boring out for a cylinder. Cylinder diameter is smaller, and the way geometry works, if you have half the diameter, you actually have a quarter of the material. So it's a lot less work, and then that's a lot less stuff to take out. One of the big difficulties in boring tunnels is you got to get rid of the stuff after you dig it out. There's less stuff to get rid of. Another big step is repurposing the dirt. So you dig up stuff and you excavate the tunnel and you got all this stuff. The boring company is working on repurposing the muck as bricks and pavers for housing projects, embankment beautification, other uses. I believe they're talking about making bricks for 10 cents a piece, boring bricks. We've talked about that before. It's not new, but it's new on the FAQ. Last one, designing and using all-electric tunneling equipment. By doing the tunnel with all-electric tunneling equipment, including a segment liner truck, results in a cleaner tunnel with simpler ventilation requirements. When you use diesel, it's emitting a lot of fumes and you have to ventilate the tunnel. Otherwise, you're going to get carbon monoxide poisoning or other kinds of pollution. If you're using electric machines, then you don't have to worry about fumes. A great advance. Next, they talk about the loop system. This is a new thing. I think we knew a lot of this, but they've put it in a way that it's easier to understand now. What is loop? Loop is an all-electric, zero-emissions, high-speed underground public transportation system in which passengers are transported via compatible autonomous electric vehicles at up to 150 miles per hour through main artery tunnels between stations. AEVs are Tesla vehicles, models S3 and X, that operate autonomously within the loop system. They specifically refer to models S3 and X. Presumably they would also include Model Y, Cybertruck when it's available. I would assume that they would allow Cybertruck. Maybe it's too wide, but I don't think it's any wider or significantly wider than Model S or X. A lot of us think there will be a Tesla minibus that would allow a larger number of passengers to be used. One of the things I talked about with Will is maybe there will be mass transit tunnels that are designed and used with high-capacity vehicles like a Tesla minibus, and maybe there will be other tunnels that will be used by you're driving down the road and you can just drop into a loop and avoid traffic. It's not clear how much they're going to do one or the other. We think that's coming forward, but that's the idea of how flexible tunneling is, what kind of flexible systems you can create. From what I can see, the Las Vegas tunnel system and the dugout loop and the Ontario County system at the Ontario County Airport, those are not going to be for regular Tesla vehicles that just pop in and drive along. Those are going to be for purpose-built vehicles to take larger numbers of people from point A to point B, like from the airport to the train station, or from the transit system to the Dodger Stadium, or from Las Vegas and the convention center in Las Vegas, and maybe from Las Vegas Airport to some casinos. But stuff they've done so far is not designed for regular people who are driving down the road to say, hey, there's a lot of traffic here, I think I'll drop into a tunnel. That doesn't seem to be what they're doing yet, although I think that's the future. They talk about different types of stations. This was a nice thing, and I'll include the pictures here. There's a surface station, which is what it looks like from up above. There's a subsurface station. You can see what it looks like down below. And then there's an open air station. And they don't really explain much of this. I think it's sort of self-explanatory, but I think the idea is an open air station is probably one that's in a less densely populated area, and that's just a quick stop for people to get out, where the surface and subsurface stations are main stations. So there's more detail here. What is the ridership capacity of Loop? Loop ridership is a function of the number, size, and spacing of stations. Generally, high-volume loop systems target 10,000 people per hour. That sounds like a lot of people. If a system requires greater ridership, you just add more tunnels. If a system requires much lower ridership, the tunnel system remains the same and smaller, less expensive stations are constructed, I think like that open air station that we saw a minute ago. How much would a trip cost? Fare prices are project specific, but they predict they will be comparable to or lower and current public transportation fares. Again, I think this depends. Are you riding on their vehicle or are you driving through on your vehicle? Not sure where that's heading. How is Loop different from a subway? Loop is an express public transportation system that resembles an underground highway more than a subway system. Passengers arrive directly at their final destination without stopping by traveling through a main artery tunnel and using side tunnels for AEV entry-exit. And they put it another way. To put it another way, if a subway line had 100 stops, a train would typically stop at each station. So the trip between stop 1 and stop 100 would be long. In contrast, Loop passengers travel directly to their destination, anywhere between stop 1 and stop 100, without stopping at the intermediate stations. The express system allows Loop AEVs to travel faster than conventional subway cars, up to 150 miles per hour versus up to 65 miles an hour. And they did include a video on the website, and you can see a Tesla vehicle going what appears to be 128 miles per hour. There's another interesting point. I've seen this criticism before. There was a video about how difficult it would be to have people come in and out of stations. There'd be a bottleneck at entering the loop or exiting the loop. And the Boring Company has an answer for that. Unlike a subway, there's no practical upper limit to the number of stations that can be built along the tunnel route, because stations can be as small as 2 parking spaces. You literally can make a really small station and just the car there's like an elevator to get you back up to the station. Since stations require such a small footprint, they can easily be integrated in busy city centers, parking garages, and residential communities. This high density of stations will distribute AEV and foot traffic across many access points, providing more convenient entry and exit locations and reducing congestion in populated areas. If needed, larger stations can be built to increase ridership capacity. So this is a key difference between the way people perceive it, that there's somehow a problem. You can, basically, the short answer is you can make a lot of stations so people can get off closer to where they want to be. And doing it that way makes the stations more efficient and prevents them from becoming bottlenecks. It talks about safety during the COVID-19 pandemic. I think that's a short-term topic. They believe that they can make them safe, and same way that you make other things safe. They ask about Hyperloop, and the answer is Hyperloop is an ultra. This is important. Hyperloop is more distant in the future, and I'm glad they specifically address it. Hyperloop is an ultra high-speed underground public transportation system in which passengers are transported at 600 or more miles per hour within a vacuum-sealed tunnel. Whereas Loop is used for shorter intra-city routes inside cities from point A to point B within a city, Hyperloop will be used for longer intercity routes. And they specifically note that the Boring Company's current tunnels are designed and built in preparation for their eventual transition to Hyperloop. This is a big deal.
And then one day it will connect to the Hyperloop. But that's for another time.
There's this open question, will Hyperloop run above ground or underground? And a lot of people have said, oh no, Hyperloop will run above ground. And this is a very clear statement from the Boring Company that their intention is to run Hyperloops underground in Boring Company tunnels, because they say Hyperloop will be used for longer intercity routes, and the tunnels are designed and built in preparation for eventual transition to Hyperloop. One of the key details here is it has to be a vacuum-sealed tunnel that allows them to lower the amount of air to reduce the air pressure in the tunnel, which allows vehicles to go without having to fight the air friction, air resistance, wind resistance. By getting most of the air out of the tunnel, they have much less wind resistance, and it's easier for vehicles to go much faster with very little resistance. And that means you can go faster, and it means you use less energy to go faster. And there's all kinds of problems. If you go fast in a tunnel, you got to push the air out of the way. The air has to go somewhere. This removes all those problems. So a very promising thing to see this about Hyperloop. Really quick, they mention safety, and in particular, they talk about the safety of Tesla vehicles, that the Tesla Models 3, S, and X have achieved top ratings of 5 stars and low probability of injury. I don't think that's any new information. It's worth seeing. If the plan is to use Tesla vehicles, they will be safe. The reality is there shouldn't be crashes in the tunnels in the first place. So I'm not sure why that was added. Hopefully there won't be any crashes in tunnels. If there are crashes in the tunnels, we got bigger problems. Especially if you're going 150 miles an hour. I'm not sure how much vehicle safety is going to help you at that speed. Another common question people have is, how do people evacuate? And they say loop tunnels will have emergency exits along the tunnel route. However, unlike most subway systems, Loop has no internal hazards. There's no 600-volt third rail. And the entire paved surface serves as an emergency walkway. The egress path, which is how you get out, is thus safe and wide despite the reduced tunnel diameter. What about a fire? The risk of fire is very low. There's no internal combustion engines. There's no gasoline. The tunnel lining is non-flammable concrete, and there's no flammable materials added. There's no live electric third rail. So it minimizes potential fire sources and eliminates the potentially dangerous effects of water intrusion, which is unlikely anyway. Tesla's vehicles can safely handle some rain, if there is rain. In the unlikely case that a fire does occur, the tunnel's ventilation system will remove the smoke to allow passengers to safely evacuate. This should not be a problem. The FAQ briefly addresses earthquakes. This is another common misconception people have, and I've seen them talk about this before, so this isn't really new information. Tunnels are actually a very safe place to be in an earthquake because no building can fall on you when you're in a tunnel. Tunnels actually don't move as much as the ground does when there's an earthquake. Loma Prieta earthquake, which I survived in 1989 in Northern California, the San Francisco area, there were no damage to tunnels, and those were used to transport rescue personnel. Tunnels are actually great for earthquake situations. So other uses, what about utilities? These tunnels are really well designed to be used for utilities, whether it's water pipes or other things. The tunnels are going to have a typical minimum depth of 30 feet. So that will be well below most utilities. They're not going to run into power lines or other water lines. Most utilities are typically less than 10 feet below surface, so it shouldn't be a problem. But if there is a situation where utility is located deeper, it's easy to make the tunnel deeper. Is there disruptive surface vibration or noise during tunneling? I think we already addressed that, but tunneling is, because they're so far down, once you're 2 tunnel diameters down or 28 feet down, and they're going to be more than 30 feet down, the tunneling process is almost impossible to detect. There's typically more surface vibration felt from a pedestrian walking nearby than from a tunnel boring machine operating 30 feet below. What do you do with all the dirt? Typical projects, they ship the dirt off-site to disposal locations. It's costly, time-consuming, noisy, and environmentally bad. They recycle the muck into useful bricks, used to build anything. Not a new concept. Buildings have been done that way for years. Make sure you check out my interview with Will from Boring Revolution here. I've got other great videos for you to watch. Really popular video right now is 5 surprises from Elon Musk. Check out my video about Neuralink, where Elon Musk talked to Joe Rogan and explained a lot about what's coming with Neuralink. Really fascinating stuff. And otherwise, please subscribe. Thanks for watching.
And that concludes our presentation. Thank you.